That is this recording? Yes, it is. Great, awesome. Okay, so let's continue with what we have been doing. So I aim that today is the last lecture of material. So we will try to finish the material by today. So we'll continue with these two problems. So please try to find a spot as fast as you can. So we'll continue working with this problem. Find okay, so please, as fast as you can, please find the first spot where you can sit. You don't need to sit next to your friends. Okay, so find dimension of the rectangle of largest possible area that can be inscribed and the unit circle. So I have my unit circle here, and I have the vertex of the rectangle xy. The first vertex. So in the first positive quadrant, in the first quadrant. Now, what is this vertex? What are the coordinates of this point? What are the coordinates of this point, everyone? X minus y. Awesome. What are the coordinates of this point? Minus x minus y. And what are the coordinates of this point? Minus x, y. So these are the vertices of my rectangle. What is the area of my rectangle here? It's the height times the width. So it's 2y times 2x. You see this? Area is 2x times 2y. Of course, here x and y are positive. You guys see this, right? I picked x and y to be the vertex in the first quadrant, and x squared plus y squared is equal to 1. So the area is 4xy. How many variables do I have here? 2. Now, can I do any reduction? I have that x and y are positive, and x squared plus y squared is equal to 1. Can I solve for y in terms of x? I know that y squared is 1 minus x squared, right? Now, this equation has two possible solutions. It's root of 1 minus x squared, or y is equal to minus root 1 minus x squared. Now, why here can I choose? What is the constraint that allows me to say that I can solve for y in terms of x? Yes? Y is greater than 0. So y squared is equal to 1 minus x squared. So y is equal to square root of 1 minus x squared. Since y is positive. Great. So the area is 4xy of course for x between 0 and 1. You guys see this? The largest possible value of x, what is the largest possible value of x? 1. Now really, I prefer not to put the, I prefer to keep it this way. Okay? Because x can't be 0 and x can't be 1. You guys see this or not? Okay? X cannot be 0 and x cannot be 1. Now if you put the inequalities, it's not a big deal. Okay, it's not that you have a negative value. Okay, so if you put the inequality, if you put them here, if you put less than or equal to, this is also fine. It's not a big deal. Okay, but let's stick to this. So let f of x. I mean, what we could do here is we could do the closed interval method, or we could do with the derivative. What do you guys prefer? Derivative. Derivative? Okay, great. Let f of x be is 4x square root 1 minus x squared, or I'll just put it this way, 0x1. That's not a big deal, okay? That's not a big deal. What is f prime of x? F prime of x is 4 square root of 1 minus x squared plus 4x. What's the root of root 1 minus x squared? So what's the root of the root? It's 1 over 2 root 1 minus x squared times the root of 1 minus x squared, which is minus 2x. So f prime of x is 4 square root of 1 minus x squared. So the 2 goes away. So you get minus 4x squared over the square root of 1 minus x squared. Put everything under a common denominator, right? Multiply everything by square root of 1 minus x squared. What do you get? You get the 4 times 1 minus x squared minus 4x squared. I hope I did not mess this up. I may have messed it up. Let's see. 4x 1 minus x squared. So it's 4. No, that's good. 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 1 minus x squared. Okay, what happened here? Okay, so what is f prime? Are we following? Are we following how I got f prime of x or not? Yeah, are we following, everybody? Any questions on this, please do not hesitate to ask. Are we following or not? Do we know how to differentiate this stuff? Okay, great, awesome. So it's 4 minus 8x squared over the square root of 1 minus x squared. So let me just factor out the 4. Of course, the derivative is defined on the open interval 0x1. Awesome. Now, what are the critical numbers on this interval? I have to solve f prime of x is equal to 0, right? Well, yeah. The problem, anyways, critical numbers, or let's do just a first derivative chart. So f prime of x is equal to 0. This implies that 1 minus 2x squared is equal to 0. This implies that 2x squared is equal to 1. This implies that x squared is 1/2. So x is 1 over root 2, or x is minus 1 over root 2. Now, are these two valid critical points in my case or not? In this case, are they valid both? Are they both valid? What is the one that I have to pick, and what is the one that I have to eliminate? Please raise your hand, saying your reason. You want to answer? Yeah. The negative one we have to. Why is that? Exactly, because x is between 0 and 1. Since x is between 0 and 1, we reject, well, we reject. Okay, and we only consider over root 2. Now let's just do the first derivative chart. X, f prime, and f. I have 0. I have 1 over root 2 here, and I have 1. So f prime is 0 here. So f of 0 is 0, and f of 1 is also 0. Now, what do you expect it? You expect f to go up and then go down, right? This is what the question should look like, right? This is what the question is asking, and the question can't be wrong. And besides, this function is always positive on 0, 1. Did you notice this? So like really, it has to go up and then go down. If you get something else, then you might need to recheck the calculations. Now let me take a number between 0 and 1 over root 2. What's the number between 0 and 1 over root 2? 1 over 10. You could do that. So, I mean, technically what you can do is just pick a number bigger than root 2. Pick a number bigger than root 2, right? So say, what is a number bigger than root 2? 2. Okay? So 1 over 2 is less than 1 over root 2. Okay, pick up. Okay, are we good here? This is how I picked it. Great. Now, let's pick 1 over 2. X is equal 1 over 2. So f prime of 1 over 2, what is that? I have 4, it's positive. 1 minus 2 times, yeah.
So in the Antiderivatives, they were not allowed to calculate. Which roots would you recommend memorizing the numerical values for? Like, I don't know.
You did not need to memorize any numerical value.
Great. So does that work for every single root?
Well, so root x, so root 1 is less than 1, root 2 is less than 2. For any number bigger than 1, the root of it is less than itself.
Okay.
Right? You don't need to memorize it.
Okay.
Okay? Great. So 1 over 2. So plug in 1 over 2. Or worst case scenario. Worst case scenario, what do? You just sketch this thing, right? Sketch this thing. What do you get? You get something like this.
Yeah.
Okay? So here it's positive. Here it's negative. Plug in 1 over 2. So you get 4 times 1 minus 2 over 1 over 4. So 1 minus 2 times 1 over 4 is 1 minus 1/2, which is plus. And you have a positive number, so you get positive. Now pick a number between 1 over root 2 and 1. Pick a number, I don't know, well, strictly less than root 2, that's a bit, yeah, okay, it's not gonna, yeah. But, I mean, you can see that from the graph here. Goes down. Now, what's f of 1 over root 2? F of 1 over root 2, it's 1 over root 2 times square root of 1/2. So it's 4 times 1/2. So f of 1 over root 2 is 4 times 1 over root 2 times square root of 1 minus 1/2. So what do you get? 4 over 2. So you get. Okay? Are we good here? Are we good, everybody? Yeah, we got this. Let me write here. I don't want to erase there. Or you know what? Can I erase here? Or I'll erase the question. So, the largest. So the maximal area. So you know F. So the maximal area is 2. Since 2 is an absolute max of F on what? On 0, 1 is the absolute max. And the dimensions of the rectangle are x is equal, or what are the dimensions of the rectangle? The dimension of the rectangle are 2x, which is 2 over root 2, and 2y, which is 2 square root of 1 minus x squared, which is 2, 1 over root 2. This is equal to 2x is equal to root 2. Okay, this is why I asked for the closed interval method here would lead to something easier. We didn't have just to plug in f of 0, f of 1, and f of 1 over root 2, and then compare these three numbers, right? If you had looked at the closed interval method, you just have to plug in these things. F of 0, which is 0, f of 1, which is 0, and f of 1 over root 2, which is a positive number. Okay, great. Are we good here or not? Yeah. Yes.
Could you just quickly show how you do it through the closed interval method?
To the closed interval method. Awesome. So you're here, right? You reach the critical point. So maybe I'll do it here using the closed interval method. Absolute max and min of f of x is equal to 4x square root 1 minus x squared. Now on 0, 1. Now critical numbers. And 0, 1 is 1 over root 2. F of 0 is 0. F of 1 is 0. And f of 1 over root 2 is 2, right? Absolute min and absolute max. Is 2. Absolute min is 0. By the way, the absolute min and the absolute max are f values. These are not x values, okay? So please pay attention to this. The absolute minimum is an f value. It's a y value and not an x value. Okay, is it clear? Yes? Great, awesome. Great. Now let's do another one. Find the dimensions of the rectangle of area 100 whose perimeter is as small as possible. So let x and y be the dimensions of this rectangle. What can you say about what function do you need to minimize? You need to minimize the perimeter. To minimize, what is the perimeters of the rectangle in terms of x and y? Everybody? 2x plus 2y. We need to minimize 2x plus y. What condition am I given? That the area is 100. How do I translate that into an equation with the variables I know? With xy is equal to 100. Okay, great. Now 2x plus y. How many variables do I have here? Let's look at the function I need to minimize. How many variables do I have here? 2. Everybody, are we focusing? Now, can I manage to get rid of the one of the 2 variables?
Yes.
How do I get rid of them? Or one of these? Yes, sir? Y is equal to 100 over x. Very good. Now y is equal to 100 over x. So 2x plus y is equal to x plus 100 over x. So we need to minimize f of x. Now, what is the 100? That 100 on x, that one. On what interval do I need to minimize x? What are the possible values of x? X is the dimension of the rectangle. X is the dimension. What x? Can x be negative? No, but can x be as large as possible? Yes. You see that? Right? If x is 1,000,000, then y is 100 over 1,000,000. Right? If x is 1,000,000,000, then y is 100 over 1,000,000,000. If x is 10 trillion, then y is 100 over 10 trillions. Right? You guys see this? So x can be positive 4 on what do I need to do? What do I have to take? First of all, I take the derivative. Who can help me with the derivative? That should be an easy one. F prime of x is equal to 2. Derivative of x is, everybody, the derivative of x is what? 1. Derivative of 1 over x is minus 1 over x squared. So always try to have it factored if you want to. So you get x squared minus 100 over x squared. Great. What are the critical numbers? Critical numbers n0 infinity, what are they? Everybody? And the interval 0 infinity. What are the critical numbers of n? Who wants to answer? Yes?
Plus or minus 10.
Plus or minus 10, very good in general. Now, are both of them valid?
Oh, not x.
No, not x equal minus 10. So the critical numbers in 0 infinity is only
10.
Very good. In 0 infinity 10. Right? Is that clear or not? Is that clear? Everybody, is that clear why?
Yes.
Why minus 10 is not acceptable? If it's not clear, please let me know. Okay, awesome. Now, I have to do my first derivative chart. So, I have x. F is not defined at 0. And I have f prime. And I have f. And I have 10 here. Plus infinity. F prime is 0 here. If give me a number between 0 and 10, who wants to try to fill the signs? Anyone wants to volunteer for the signs of the derivative? Yes?
We can plug in 1, which is between 0 and 10.
Plug in 1 between 0 and 10, so f prime of 1 is, yeah, so it's positive, negative over positive, so you get a negative number, awesome. And then here?
Then we can plug in 11.
11, so f prime of 11.
And that would be positive.
Positive, positive over positive, because this is just positive. Then f goes down, and f goes up. What is f of 10? F of 10 is 2 times 10 plus 100 over 10. It's 2 times 20. Is that true? Which is 40, right? So, the absolute minimum. Of f on 0 infinity is 40 at x equal 10. Now, what is the value of y? So one dimension is 10. What is the other dimension? The dimensions are x and y, right? What is the other dimension? The area is 100. xy is 100. If x is 10, what is y? 10. Are we good? Great. Hence, x is equal to 10 and y is equal to 100 over x, which is 100 over 10, which is 10. Okay? Great. We're now done with optimization. And we're going to start a new, the final section of this course. Any questions on this stuff? Great. I'll keep it upstairs. Antiderivatives. Antiderivatives. Guys, hey, any questions? What's up? Yes?
So we find the maximum and minimum points, but we also have to find the limits of B if it's like the lowest.
That's a very good question. That's a very, very good question. That's a very good question. So when we said the maximum here and the minimum there, you meant in the example here? Okay, so that's a very good question. Now you can do this for yourself, right? Just to double check your answer. But here you know that the function is going down and then going up. So is the limit at infinity bigger than 40 or smaller than 40? What do you expect it to be?
Bigger.
Bigger, right? Because you're going down to 40 and then you're going up. Now let's double check this. Limit as x equal to infinity. This is infinity plus 0, right? So this is infinity. Now, as x goes to 0 plus, this is 0 and this is infinity. So it's infinity. Now, do you need to do them? No. Because to prove a global minimum, you just have to prove that any value is bigger, right? So you do that, and it goes here. So here must be the minimum, regardless of the limits. You see that?
But then when do you have to prove it by finding the limit at infinity?
Pardon me?
When you have to prove it by finding out that the limit as x approaches infinity is greater.
Yeah. So here really you prove that f is decreasing from 0 to 10, right? You proved f wherever it starts, it's decreasing, and then it must go up. You see what I'm saying? So what is the lowest point of f? 40. Okay, regardless of the limits. But I mean, for yourself, you can check the answer, right? If you get a limit here that is 30, then there's something wrong. Okay, but that's a very good question. In sketching, we have to do the limits, right? Because you have to sketch the curves. Okay, is that good? But if you feel comfortable putting the limits, if you want to put the limits, please don't hesitate.
So when we write it, do we just assume that like we don't need to prove it and we can just write the minimum?
Yeah, exactly. You just have to prove it's a minimum. Here, it's a global min. Here, it's obviously a global min, right? Because it went down and then it went up. Is that good? Okay, great. Awesome. Now we start with the final section. Antiderivative. We say that f is an antiderivative of a function f on an open interval I if f prime is equal to f on I. Example: x squared over 2 is an antiderivative of x on R. Why is that? Because x squared over 2 prime is x. Okay, so we say that big F is an antiderivative of little f if just the derivative of big F is equal to small f. Are we good here? This is just an equation. This is just a definition. Great. Now, let's see, cosine x. So I want a function whose derivative is cosine. What is a function whose derivative is cosine? Who can give me an example of a function whose derivative is cosine? Yes. Negative.
Oh, sorry, sine.
Sine.
Yes,
Exactly. So sine x is an antiderivative of since it's cos x. Let's do one more. antiderivative of 1 okay. Let's make it more slightly more interesting. I want a function whose derivative is 2 over 1 plus x squared. Who can help me with this? Yes, sir.
2 arctan of x.
2 arctan of x, right? What's the differentiate 2 arctan of x? What do you get? 2 over 1 plus x squared. Very good. Okay. Okay, spice it up a bit. Not a big deal. So I want an antiderivative of minus 3 over square root of 1 minus x squared. So I want a function. When I differentiate it, I get minus 3 over square root of 1 minus x squared. Any ideas? Please raise your hands. Oh my god, what did I write? Yes, thank you. 2 arctan x or 2 tan inverse of x. Thank you. Okay, who can help me with this one? I want a function whose derivative is minus 3 over root 1 minus x squared. Remember your functions, okay? Which function has derivative related to 1 over root 1 minus x squared? Three arc cosine x. Are we good here? Anybody thought of another antiderivative? If I take minus 3 sine inverse x, is that an antiderivative as well? Yeah, because differentiate minus 3 sine inverse, what do you get? Minus 3 over root minus 3 sine inverse x is also an antiderivative. Right? This business is easy, right? It's nothing hard, is it? Okay, great. Now, okay, great. Now, I want an antiderivative of secant squared on minus pi by 2, pi by 2. What's an antiderivative of secant squared on minus pi by 2, pi by 2? Please raise your hands. Yes, sir? 10x. 10x, right? What's the root of 10x? Secant squared, right? Okay, let's do one more. Who wants to help me? So I want an antiderivative of secant 10 on minus pi by 2, pi by 2. So I differentiate a function whose derivative is secant 10. Secant of x. Could you give me another function whose derivative is secant 10? Secant 10 is correct. Very good.
I can't think of it off the top of my head, but sure there is.
Third, you should not think too hard. That's the thing.
I already know this before.
So secant x is a good antiderivative. Okay, now if I add 1 to secant x, does the derivative change? So is secant x plus 1 an antiderivative? Yeah. Secant x plus 2. Secant x plus 5. Secant x minus 24. Secant x minus 3 million. Are these antiderivatives or not? So secant x plus 1, let's say, is an antiderivative. Great. This is the question you always should ask yourself. Okay. Now, suppose f1 and f2 are two anti-derivatives of f on an open interval I. Then f1 prime is equal to f2 prime is equal to f on I. Do you remember this or not? If I have two antiderivatives of the same function, then their derivatives are equal to f, right? On the open interval I. Let us remember, what did the mean value theorem tell us? It said that then, hence, by the MVT, or by a consequence of the MVT, f1 is equal to f2 plus c for some constant c. You agree or not? You remember this? When we proved two functions are equal on an open interval, we differentiated them, right? We saw that they have the same derivative, hence they must differ by a constant, and then we plugged in a number to show that this constant is 0. You remember this or not? Now here, what does this say? It says that any two antiderivatives must differ by a constant. So really, secant x plus c is the most general antiderivative of secant 10. Let's give an example. Then, then x plus c, is the most general antiderivative of 1 on R. What do we write? We write this symbol here, this S symbol, 1 dx is x plus c constant. Okay, folks, is that clear? Is that everybody? Is that good? What are these? What is this? What does this mean? You'll worry about it next term. Okay, you'll worry about it in 2 months. Now, don't worry about it. This is just a symbol. This says antiderivative. Okay? Great. Let's get used to this notation a bit more. Great. Integral of sine x dx. Well, integral, I didn't say anything. Antiderivative of sine x. What is that? So I need a function. Well, let's do something nicer actually. Let's do something nicer. Let's put a 2 sine or a minus 2 sine x here. What's an antiderivative of what's the most general antiderivative of minus 2 sine x? I need a function whose derivative is 2 cosine is minus 2 sine x. What is this function? Yes.
2 cos x plus c.
So let's so this is just 2 cos x plus c. Since always, if you differentiate this, what should you get? Everybody, what should you get? You should get this thing. Okay? Since d by dx of 2 cos x plus c is minus 2 sine x. Great. Let's spice it up a bit more. I want an antiderivative of 1 plus x squared plus e to the x dx. So, I want a function such that when I differentiate this function, the most general function, when I differentiate it, I get 1 plus x squared plus 2 e to the x. How should we proceed? Yep. X, yeah. You want to try? So I mean, the idea is that when you want something that you want to when you differentiate, you want to get x squared, right? Everybody.
Yeah.
Let's look at this. You want something, when you differentiate it, you get x squared. So what should the power that you differentiate be? 3, right? So you agree that you must have an x3. Agree or not? Now differentiate this x3. What do you get? You get 3x squared. Now this 3x squared needs to be 1, right? So why don't we just multiply it by 1/3? Differentiate that. What do you get? X squared. Okay? Plus 2e to the x. What's a function when you differentiate you get 2e to the x? This one you can't get wrong. 2e to the x. Very good. Plus c. Is that clear, everyone?
Yes.
Any questions? Yes, sir.
Why do the dx?
Why?
Yeah.
Why is it dx?
What's the point of it?
Oh, you'll see later. Okay, in 2 months, you'll see what's the point. Now take this as a notation. Okay? Great. Now, an antiderivative of uh, 3 What is this? This looks a bit hard, right? What is it? Guys, please. Yeah.
I have a question.
Yes.
You-
This is cube root of x to the 4th. Again, let's not think very hard. Now this cube root business, do I know how to undifferentiate, or I should write it as a power? It's better to write it as a power, right? Cube root of x fourth, what is that? This is x to the 4/3, right? Plus. Great. Who can help me with this? Now, is that clear or not? Everybody, is that clear? Great. So you want a function. Let's think about it this way without trying to memorize formulas. You want a function such that when you differentiate, you get x to the 4/3. Right? So you must have a power of x, right? By the power rule. What's the power that you need to differentiate to get x to the 4/3? 4/3 plus 1, right? What is d of dx? Well, we have no more space, let's write it here. You need to get an x to the 4/3. You agree that you must differentiate x to the 7/3. You agree? Differentiate x to the 7/3. What do you get? You get 7/3 x to the 4/3. Are we good here? If you differentiate x to the 7/3. Now, is that what you want? Do you want the 7/3 x to the 4/3, or you want just x to the 4/3? By what constant must you multiply this one to get 1 here? 3/7. Exactly. 3/7. Okay, so you get 3/7. Plus, who can help me with this antiderivative? I want a function whose derivative is 2 square root of 1 minus x squared. What is it? Please raise your hands. Raise your hand. Yes. Plus 2 arc sine x plus c. Thank you very much. Minus 2 arc cos x plus c works very well as well, right? Okay, now let's see the formulas, since you like formulas. But again, you don't need to memorize them. Now, if n is different than minus 1, what's a function that you differentiate that you get x to the n? Again, you need a power of n, you need a power of x, sorry, that when you differentiate, you get x to the n. What is this power of x? X to the n plus 1, right? So you have an x to the n plus 1 here. Now differentiate x to the n plus 1. What do you get? You get n plus 1 times x to the n. Is that what you want here? No. So what do you have to divide this one by? N plus 1. Plus c if n is different than minus 1. Double check. D by dx. As x to the n. Still have 2 more minutes. Let me just do one more example. Great. Okay. Antiderivative of ln x. Of ln x. Of 1 over x dx. What is that? Everybody? It must be a ln, right? Now notice that if x is negative, I know that ln of minus x, which is defined for negative value of x, has also derivative 1 over x, right? So really the most general antiderivative of 1 over x is ln of absolute value of x plus c, depending on the interval you consider, whether this interval is 0, infinity, or minus infinity to 0. Maybe we can do one more. Let's look at this one. An antiderivative of x times 2 minus x. Now, in Math 140, whenever you have a product or a quotient, you have to simplify it to a sum. In Math 140, okay? In Math 140, it's very important to say in Math 140, right? But it's not going to be the case next term, but in this course, simplify products and quotients to sums and to, well, that's it. Well, anyways, that's it. No, that's it. Okay, great. Now let's simplify this to a sum. Can I expand this as a sum? So what do I get? I get 2x minus x squared. What's an antiderivative of 2x? What's an antiderivative of 2x? A function when you differentiate, you get 2x. What is that?
Squared.
X squared. I mean, you can do it this way. It's 2. You use this formula, x squared over 2 minus. What's an antiderivative of x squared? It's x cubed over 3. Plus. Okay, great. So the curriculum is done. Okay, so, well, okay, well, great, awesome. Sadly, I'm paid for 5 extra lectures, so I have to do them. Well, not sadly, but you know, I'm very happy actually that we're done early. And then we're gonna do review, okay? So I'll be posting, guys, please, like, just 1 more minute. That's fine. You're gonna. So I will post like questions on my courses. You're gonna have to do them. And then we can answer them. Okay? They're gonna englobe almost everything from, let's say, implicit differentiation to now. But we will focus a lot on the chapter 4. Okay? Great. So